Hello everyone. Welcome to the solution of LeetCode problem 1523 named Count Odd Numbers in an Interval Range. In this problem, we are given a range and we have to determine how many numbers are there is odd, or we can say that we have to determine the frequency of odd numbers in this range. Now let's understand the first example. Here the lower value is 3 and upper value is 7. So the range is in between 3 to 7. So we can see that there are 3 odd numbers between 3 and 7, which are 3, 5, and 7. And in the second example, the low value is 8 and the high value is 10. And there are only one single odd numbers between 8 and 10, which is 9. And the constraint are low value can be always equal or less than to the high value, and both of the low and high value can be in between 0 to 10 to the power 9. Anyways, I hope you understood the problem. Now let's move on to the solution. Before jumping into the solution, I want to tell you something. These types of problem basically belongs to the easy category. Actually not easy, they are the easiest in the domain of problem solving. But if you go in any company's technical interview round, you will find at least one too much easy problem. And sometimes the candidate fails to solve this kind of silly question. So I am making this video to avoid this kind of silly mistakes. Anyways, now I hope you understood what is the significance of the easy problem in the technical interview round. And now let's move on to the solution. I am using one custom example to understand the algorithm behind this problem. Here, I am taking a range in between 3 to 9. So the value are the 3, 4, 5, 6, 7, 8, 9. And we have to determine how many numbers in this range are odd. Or you can say that we have to determine the frequency of odd numbers in this range. Anyways, at first we have to use a loop to iterate over all of the value in the range. So now in the first iteration, we are currently presented at element 3 or number 3. Here we can tell that 3 is odd number. But what is the mathematics behind this? If we perform the modulus operation between 3 and 2, the answer will always be 1. So we can say that 3 is an odd number. Now we are in the element 4, and again we have to perform the modular operation between 4 and 2. So we can say that the modulus between 4 and 2 is 0. Now there is an observation. The observation is, if we pick any numbers which is odd, then the modular operation between this odd number and 2 will result always into 1. And alternatively, we can say that the modular operation between any even number and 2 can be always equal 0. So here we are actually using this logic to solve this problem. Now again, we can say that 4 is not an odd number. Now we are in the element 5. So if we perform the modular operation between 5 and 2, the answer will be 1. So we can say that 5 is an odd number. And similarly, 6 is not an odd number, it is an even number. And 7 is an odd number, 8 is an even number, and 9 is an odd number. And when we find an odd number, we will increment the counter. When we find the first odd number 3, we will increment the counter value from 0 to 1. When we find the second odd number, which is 5, we increment the counter value from 1 to 2. When we find the odd value of 7, we again increment the counter value of 2 into 3. And finally, when we find the element 9, we also have to again increment the counter value. Now our counter value is 4. So we can say that there are 4 odd numbers in the range between 3 to 9. I hope you understood the algorithm. It is a pretty much straightforward mathematics, and you will find at least one of this kind of problem in the technical interview, hopefully, if anything does not go wrong. Anyways, I hope you understood the algorithm. Now let's move on to the code. The code is pretty simple and straightforward. At first, we are given a function, count odds, which has two parameters. The first one is low and the second one is high. And this method will return an integer value. At first, now we have to declare a variable named count. You can name it in any name as you want, but I am considering it as count because of the readability of the code. Now we have to use a for loop from the low value to the high value. You can use while loop or do while loop, whatever you want. But for the sake of simplicity, I am using for loop. Now we have to check in each iteration whether the modular operation between our current I and 2 is 1 or not. If it is, then we have to increment the counter value. If not, we simply increase the value of I. And finally, we have to return the value of count. I hope you understood the code. Now let's move on to the time and space complexity of this problem. In this problem, the time complexity is big O of n, because if we want to find the frequency of odd number in a given range, we have to use a loop to iterate all of the elements into this range. So here the time complexity is big O of n, and n is the number of elements presented in the range. And the space complexity of this program is big O of 1, because we are using only one constant extra space to store the value count. I hope you understood the time and space complexity. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.